This question comes from Andrew Brown, who asks what would happen if the Earth and all terrestrial objects suddenly stopped spinning, but the atmosphere retained its velocity. It is an absurd scenario, which means it's perfect for a systematic scientific breakdown. To answer it, we have to start with the sheer scale of the momentum we are talking about. The rotational speed of the Earth is not constant everywhere. At the poles, it is virtually zero. But if you are standing on the equator, you are currently moving east at about 460 meters per s-econd, just over 1,000 miles per hr. If the solid Earth, the ground, the mountains, the oceans, and everything bolted down, instantaneously locked up, but the atmosphere and everything not bolted down kept its momentum, the result would be the single most devastating windstorm in planetary history. Imagine 1,000-mile-per-hour wind. You won't have to imagine for long because the atmosphere would instantly detach from the surface. In the tropics, where the speed difference is greatest, this wind would strip the surface clean. Soil, rocks, trees, buildings, cars, and, yes, people, would be launched eastward at supersonic speeds. The wind itself would be traveling faster than the speed of sound, creating a continuous global sonic boom that would shatter any remaining structures. The friction between the atmosphere and the suddenly stationary ground would generate enormous heat, igniting forests and cities across entire continents as the wind swept over. But the wind isn't the only problem. The oceans are also moving. If the solid seafloor stops, the water will not. The water near the equator, miles deep, would slosh violently eastwards, generating titanic tsunamis that would scour the coastal regions and rush inland, riding the supersonic atmospheric current. This is a two-wave disaster, the atmospheric pulverization followed by the oceanic wave. Nothing on the surface would survive the first few minutes. If you want to live through this, you need to be somewhere that's already stationary or perfectly shielded. Near the poles, the surface rotation speed approaches zero, meaning the atmosphere-ground speed differential is minimum. If you were standing exactly at the North Pole, you might just feel a gentle breeze, while the rest of the planet is being flayed alive. But the safest bet is underground. If you were in a deep bunker, a well-reinforced subway tunnel, or a mine before the spin stopped, you might survive the winds and the heat. However, getting out would be tricky, as the surface is now a wasteland of pulverized debris and burning wreckage. The atmosphere would eventually slow down due to friction with the ground, but the Earth's rotation has a profound effect on global weather. It is what causes the Coriolis effect. Without rotation, the major jet streams would disappear, and weather systems would become completely different, characterized by simple massive air currents from the hot equator directly to the frozen poles. And here's the weird part, the classic Randall-Munroe conclusion. Stopping the Earth's spin would remove the planet's magnetic field. The Earth's rotation is vital for stirring the molten iron core, which generates our protective magnetosphere. Stop the spin, and the churning stops. Slowly, over a few years, the magnetic field would decay. Without the magnetosphere, the Earth's surface is exposed to cosmic rays and the solar wind, which would begin stripping away our atmosphere. If the windstorm didn't get the survivors, the loss of atmospheric protection eventually would. So, the short answer to the question, what would happen, is the total annihilation of virtually all life. The long answer is, even if you survive the initial 1,000-mile-per-hour apocalypse in a bunker near the North Pole, your great-grandchildren will eventually suffocate under a slowly eroding sky.